Good morning, friends. I welcome you all to online C class. Today we are going to discuss about binary search. In the last class we have discussed about linear search, where we have performed a linear search in a set of values. Today a similar kind of topic. This technique is also used to search for a given element in a list of values, and this searching is called binary search, and this technique is somewhat more efficient than the linear search, and we are going to discuss in detail about binary search in today's class. And if you see the flow of today's lecture, it will be like this. First, we are going to discuss about what is binary search, a little information about the binary search, and then we will discuss binary search with an example. Then we will go for evaluating the efficiency of binary search. Its time complexity and space complexity is evaluated, and then we will try to develop the pseudocode for binary searching technique. Then from the pseudocode we try to develop a C language code for binary search, and then once C language code is available to us for binary search, then we will try to develop a complete program for binary search. Then we will discuss as usual the important questions and then the assignment questions related to today's class. So let us start our discussion with binary search. Binary search is used only on ordered list. Ordered list means it is a list in which all elements are arranged in the order. It may be either ascending order or descending order. Ascending order means elements are arranged from the smallest element to the biggest element. Descending order means elements are arranged from the biggest element down to the smallest element. So binary searching technique is used only on ordered list, whereas linear search that we have discussed in the last class, it can be used both on ordered lists and unordered lists. But binary search is especially applied only on ordered list. With unordered list, binary searching technique cannot be used. So this is the limitation of binary search. Means if you want to use binary search, we have to ensure that the set of elements which we are going to search should be arranged in the order. So here we are assuming that elements are there in the ascending order. Now to search a set of elements, first we will take a key value. Key value means the key value is the value for which we have to search the list of or set of elements, and both key value and the list of elements we will take from the user, and then for the key value we will search the set of elements, and if the element is found in that set of elements or group of elements, then we will return the position where that element is found in the list or in the set of element. What is its position, whether it is there in 5th position or 8th position or 13th position of that list. So that position is returned, and sometimes element may not be there in the list. If the element is not there in the list, then we will return a value -1. A value -1 is returned means that element is not available in the list, and other than -1 if you are returning means it is the position of that element in the list. So like that we have to understand. Now what is the logic of this binary search? In the binary search we will take a key value, and this key value is compared against the middle element of the list. So approximately we will calculate where will be the middle element in the list, its position, its index position, we will calculate first, and then key value we will compare against the middle element value. And when you compare a key value with the middle element value, there are three possibilities, and one of these three possibilities may take place. What are these three possibilities? That is, the key element may be equal to the value of the middle element. That is the first case. Key value is exactly equal to the middle element value. So when the key value is equal to the middle element value, we know that the key element is found exactly in the middle position of list. So therefore, we will return the index position of the middle element, and then we will stop the searching process because our element is found. So therefore, there is no need to search the list. List is containing our key value, and this key value is there exactly in the middle of the list. So therefore, we are stopping the searching process, and then we are returning the position of the index position of the middle element. So this is what it is done, and means with one comparison itself the searching process is over. And the other case is, suppose if the key value is not equal to the middle element value, then what happens? Then what we will do is, we will check whether the key value is less than middle element value or not. If the key value, assume that if the key value is less than middle element value, then definitely we know that the key value, definitely it will be there to the left sublist of the middle element, because all elements are arranged in the ascending order, means smallest element to the biggest element. And key value is less than middle element means definitely because all the elements which are less than the middle element are there to the left side of middle element. So therefore, if key value is less than middle element means definitely it will be there in the left half of the sublist. So therefore, we will continue the search process in the left half of the sublist by ignoring the right half of the list, because in the right half of the list we are having all the elements whose values are greater than the key value. So therefore, all elements values are greater than the key element value. So therefore, there is no need to consider the right side sublist. Means with one comparison, we are almost eliminating half of the list. So therefore, the number of comparisons in the binary search will be becoming far lesser than the number of comparisons in the linear search, because by comparing the key value with the middle element, we are eliminating half of the elements of the list. So therefore, automatically the number of comparisons will be reduced. So that is what we are doing. If the key value is less than the middle element value, then we know that the key value definitely, if it is there only in the left sublist. So therefore, we will consider only left half of the sublist. We will ignore right side sublist. Suppose this condition is not true, means if the key value is not less than middle element, then we know that key value is not less than middle element means definitely key value will be there in the right side sublist, because key value is not less than middle element means definitely it is greater than middle element. Key value is greater than middle element means all the elements whose values are greater than the middle element, definitely it is there on the right side of the middle element. So therefore, our search will be continued in the right half of the sublist. Here we will ignore left half of the sublist. If the key value is greater than middle element means we will continue with the right half of the sublist. We will ignore left half of the sublist. Means in any case, whether key value is less than middle element value or key value is greater than middle element value, half of the sublist is ignored and searching process is continued in the another half of the sublist. If key value is less than middle element, we continue the search process in the left half of the sublist. If the key value is greater than middle element means the search process will be continued in the right half of the sublist. We ignore the left half of the sublist. That is what we are going to do. And these steps again in the either left half of the sublist or right half of the sublist, yes, the searching process will be again continued in the same way. Means again the key element is compared with the middle element of the left half of the sublist or right half of the sublist, whatever sublist you are taking. And again three things may be happen. So this process goes on repeating until the element is found, or we are coming across with a list where only one element is there in the sublist. Then we will stop the search process. And we are going on up to the sublist with only one element, only when the element is not there in the list, then only we are going on dividing. Means in the first phase you are having a big sublist with n elements. Once you compare the key value with the middle element, for the next phase you are having only n by 2 elements. And in the next phase, when you compare again key value with the middle element of the n by 2 sublist, then for the next phase again you are going to have n by 4 element to the next phase. Like that, in every phase the number of elements are reduced by almost 50%. And at some point of time you are going to have a sublist with only one element. At that place, since sublist contain only one element, you cannot divide that sublist further into two sublists, left sublist and right sublist. Means we will stop searching process there. But this case will be there only when the element is not there in the list. Then only we are going up to the sublist with only one element. There we will stop the search process and we will return a value -1 and represent that the key value is not found in the sublist. So that is what we are going to do. And before going to discuss binary search procedure in terms of mathematics, let us take the assumptions, the same assumptions whatever we had for linear search. So same assumptions we are taking here. So we are assuming that X be an array that stores n elements. We are taking an array X for storing n elements or n values. Okay, and we are assuming that all these elements in the array X are stored from index position 0 to n-1. 0 to n-1 means n elements we are storing. So first element is there at the index position 0 and the nth element will be there at the index position n-1. And we are also assuming that because it is a binary search, all the elements which are there in the array X, they are in the sorted order. And this sorted order we are considering it as a ascending order, means the smallest element to the biggest element. So all the elements are arranged in the ascending order in the array X, smallest element to the biggest element. And then we will take a variable called key, and this variable contains a search value. And for that search value, we will search the elements of the array X. So these are the assumptions that we are taking. And here, when we are searching for a key value in the array X, if the element is found, then we will return the index position of that element in the array X. And if the element is not found in the array X, then we will return a value -1. This is the process. And now, what is the procedure? So simple logic already we have seen. What is the logic of this binary search? The same logic we will try to tell in terms of the variables. So here, to explain this procedure, we are taking a variables like low variable and a high variable. And the low and the high variables are the variables. They are pointing the first element and the last element index positions. Low and high are the two variables we are taking. Low variable is pointing out the index position of the first element of the list, and high variable is pointing out the last element of the list which is to be searched. So initially low will be assigned with a value 0 and high will be assigned with a value n-1 because we are having n elements. So therefore last element index position is n-1. So therefore high is assigned a value n-1. So high contains the index position of the last element, low contains the index position of the first element of the array. Now we will calculate the middle element because comparison is done only with the middle element of the list. So therefore we are trying to calculate the middle index position of the middle element. So for that, we are taking a variable called mid. So mid is a variable, so which is pointing the index position of the approximately the middle element of the list. So mid is equal, it is nothing but low value plus high value divided by 2. So that will give the approximately the index position of the middle element of the list. Now what we will do is we will compare key variable value. Key is a variable which contains a search value that is already known to us. And what we will do is we will compare the value stored in the key variable against the value available at the index position middle. And the key value is compared against the middle element. Okay. So when you are comparing a key value with the middle element value of the list, again 3 possibilities are there. The first possibility is key value may be equal to the middle element. If the key value is equal to the middle element, we know our element is found in the middle of the list. So therefore immediately we will stop the searching process and then we will return the index position of the middle element. Means mid value we will return, because we know this mid variable contains the index position of the middle element. So therefore this middle element value means index position of the middle element will be returned. And suppose if the key value is not equal to the value of the middle element, then we will compare whether key value is less than the middle element value or not. If the key value is less than middle element value, then we know that key value definitely it is there in the left sublist of the middle element. So therefore our searching is to be continued only in the left half of the sublist. So therefore now we will change the limit of the high variable value. High variable value limit is now is, because we are considering only left half of the sublist. So it is left half of the sublist will be there from index position 0 to up to index position mid minus 1, because mid variable contains the approximately the index position of the middle element. Left sublist with respect to this mid element means left sublist means from the index position 0 to up to index position mid minus 1. So therefore high variable is made to point out the index position mid minus 1. So low variable value doesn't change because its value is 0. So left side sublist index positions are 0 to up to mid minus 1. So therefore high variable value only we will change. And the process is continued with the low value as 0 and high value as mid minus 1. Means the searching process will be continued in the left half of the sublist and we are ignoring the right half of the sublist. And suppose if the key value is not less than middle element value, means if this condition is not true means definitely key value is greater than middle element. If the key value is greater than middle element means definitely that key value is there in the right half of the sublist, because all the elements whose values are greater than the middle element value are there on the right half of the sublist. So therefore we are going to continue our search process in the right half of the sublist. When you are going to the right half of the sublist by ignoring the left half of the sublist, what you have to do is you have to change the limit of the lower variable. So lower variable index position now is nothing but it is mid plus 1. In this case, when you are going with the right side sublist, high variable value doesn't change. High variable value is pointing out the last element of the right side sublist. It is already pointing out, but only low variable value is changed. So that is low variable is equal to mid plus 1, means the first element in the right half of the sublist is there at the mid plus 1 position, index position. Now the search process is continued with the right half of the sublist for the elements from index position mid plus 1 to up to n minus 1. Means if the key element value is less than the middle element value, then only high variable value is changed. If the key element value is greater than middle element value, only low variable value is changed. And with this changed either the high variable value or low variable value, as the search process is continued. Again, we are going to repeat step 3, 4, 5. So this process is going on repeated. Step 3, 4, 5, 6 are going on repeated until the low until we will find the middle element, or the low variable value is greater than the high variable value. Low variable value is greater than high variable value. This condition we will reach when all the elements of the list have been searched and giving the conclusion that the element is not there in the list. Otherwise, the search process could have stopped at the step 3 itself. Okay, so it is stopped at the step 5 itself, because here we are comparing the key value with the middle element. If the key value is equal to middle element value, so then we will stop the search process and we will return. If the key value is not equal to middle element, then only we are dividing that list into two sublists, left side sublist and right side sublist. And based on the value of the key variable, we are continuing either with the left side sublist or right side sublist. So this process, if the element is not there, we are going on dividing each list into two sublists, and we are continuing with one of the sublist, either left sublist or right sublist. So this process goes on repeating until low variable value is greater than high. Where low variable value is greater than high means all elements of the list have been searched and the element is not there in the list. So therefore we will return a value -1. If the element is there somewhere, we will come across the element and its index position will be returned, and then searching process is stopped. So this is the process we are going to have, and we will see this with an example by taking some set of values, and we will try to work with an example. But before going to that, if you observe this procedure, and the binary search can also be implemented in a recursive manner, because the same step 3, 4, 5 and 6, they are recursively applied on the sublists. So therefore binary search can be I can say that binary search is recursive in nature. So therefore binary search can be implemented using a recursive algorithm. It can also be implemented using iterative algorithm. Means you can, for binary search you can have iterative algorithm, means using iterative method you can implement the binary search process, or you can implement it using a recursive process. So here we are implementing binary search using iterative process, and the way of implementing the binary search using recursive procedure, that you can take it as an exercise and you can try to implement the binary search using recursive methodology. So let us take an example of set of values and try to we will try to work it out with an example. So here we are taking the values, set of values, n value is 8, means 8 values we have taken, and see all these 8 values are stored in the array X from index position 0 to index position up to 7. 8 elements are there, so therefore last element is occupying index position 7. And see all these elements are arranged in the ascending order, means the smallest element 12 to the biggest element 94. 94 is the biggest element. Now we have taken the variables, low variable, high variable. Low variable is always pointing out the first position of the list to be searched, and a high variable is always pointing out the index position of the last element of the list to be searched. And mid value, we will calculate mid value based on the values of low and high. And key variable value we are taking here as search value as 25. So key variable value always contains a search value. Here our search value is 25. Means here we are going to search for a value 25. So all these list of elements are searched for the key variable value 25. And this key variable value is always compared with the middle element of the list. So now initially in phase 1, before we are going to start with phase 1, we are initializing low variable value and a high variable value. Low variable value is made to point out the index position of the first element. Index position of the first element is 0. So therefore low variable is initialized with value 0. And a high variable value is made to point out index position of the last element. The index position of the last element is 7. So therefore a high variable is assigned value 7. So initially this is the situation. Low variable value is 0. high variable value is 7, means it is pointing out the index position 7 where the last element of the list is there. So now for phase 1, before we are going to start phase 1, we are having 8 elements, n value is 8. Now after phase 1, we are going to divide this list into two sublists approximately containing 4 elements, left side sublist and right side sublist. We are going to continue either with the left side sublist or right side sublist in the phase 2. So let us do with the phase 1. So in phase 1, first we will calculate mid variable value. So mid value is calculated based on the values of low variable value and high variable value. So what is the formula for calculating mid variable value? Mid variable value is nothing but low plus high divided by 2. So check, what is low variable value? 0. What is high variable value? 7. 0 plus 7 means 7 divided by 2 means 3.5. So 3.5 is rounded up to the nearest integer. Up means the next nearest integer to the 3.5 is 4. So therefore mid variable value is now 4. So therefore what you have to do, you have to compare your key variable value with the element which is there at the index position 4, because mid variable value is 4. So whatever element is there at the index position 4, it is assumed as the middle element of the list. At index position 4, we are having an element 48. So therefore 48 is compared against the key value. So first we have to check whether key value is equal to the middle element value or not. So key value is 25, whether it is equal to the middle element value 48 or not. 25 is equal to 48? No, it is not equal. Our remark is not equal. So first comparison is done with the middle element. So we found that key value means 25 is not equal to 48. So then what we have to do, if they are not equal, key value is not equal to the middle element. If key value is equal to the middle element, then we could have stopped our search process here itself and we have returned the index value 4, isn't it? But here key value is not equal to the middle element value. So therefore next thing what we have to do is we have to check whether key value is less than this middle element value or not. So check whether key value is less than middle element value. Key value is 25. 25 is less than middle element value 48. Yes, 25 is less than 48. So 25 is less than 48 means definitely that element will be there in the left half of this list, because middle element is 48 and all the values which are less than the middle element value, definitely it is there on the left side. And all the elements whose values are greater than middle element value, so they are there on the right side of the sublist. So therefore key value is less than middle element value means key value definitely there in the left half of the sublist. So therefore when the key value is there in the left half of the sublist, then we have to change the high variable value. Okay, low variable value is not changed. High variable value should be changed because we have to search only this sublist. For this sublist limit is low variable is pointing out first element, high variable we have to make it to point out this element. This is the last element of this left side sublist. So therefore we will make a high variable value as mid minus 1. So mid value is how much? 4. Mid minus 1 means 3. 4 minus 1, 3. So 3 is the now latest high value, and the low variable value do not change. Means by the time phase 1 is over, we have found that the key element value definitely it is there in the left side sublist. So therefore since we are continuing with the left side sublist, so high variable value is changed, low variable value is not changed. High variable value is found as it is 3. Means by the time phase 1 is over, low variable value is 0, high variable value is 3. So for phase 2, means for next phase, we are going to search for the key value in the left sublist. So low variable value is 0, high variable value is 3. Means the searching is done only within these elements. Means in the sublist containing only these 4 elements. And this sublist is ignored because all these values are greater than key value. So therefore definitely key value is not there in that list. So therefore we are continuing only with this sublist. Now for phase 2, what we have to do? Again, the same process we have to repeat. In phase 2, low variable value is 0, high variable value is 3. So calculate middle element. Middle element is nothing but low plus high by 2. Low plus high. Low is 0, high is 3. Low plus high. 0 plus 3 divided by 2. 0 plus 3 means 3 divided by 2 means 1.5. So it is approximately, when it is rounded up to the nearest integer, mid variable value is equal to 2. So comparison should be done with the element which is standing in the index position 2. So at the index position 2, you are having 33 element. Now compare your key value with the element 33. So key value is 25, compare with 33. 25 is equal to 33? No, it is not equal. So therefore what you have to do? Then you have to check whether key value is less than this value. 25 is less than 33? Yes, 25 is less than 33. So therefore, you know that if the key value is there, definitely it is there in the left half of this sublist. So left half of this sublist is only this list. So therefore again change high variable value. So high variable value is nothing but mid minus 1. Mid variable value is 2, 2 minus 1 means 1. So high variable value is 1 and low variable value is not changed. Means for the next phase we are continuing our search only in this sublist containing only 2 elements. Means the list which contains 4 elements in this phase will be reduced to 2 elements in the next phase. So in the next, means by the time phase 2 is over, low variable value is 0, high variable value is 1. So this is the inputs to the next phase. In the next phase, our search process is continued only within the sublist containing 2 elements. See, in phase 1, 8 elements. Phase 2, we have list with only 4 elements. In phase 3, we are coming with the elements with only sublist with only 2 elements. Now, for phase 3, low variable value is 0, high variable value is 1. Now calculate the middle element of this list. How do we calculate middle element? It is nothing but low plus high by 2. Low is 0, high is 1. 0 plus 1 by 2 means 0.5. 0.5 means it is when rounded up to the nearest integer, its value is 1. 0.5 becomes 1. So comparison done with the element which is there in the index position 1. So key value is compared against this element. 25 is equal to 25? Yes. 25 is equal to 25. So therefore immediately we will stop search process and return the index position of this element in the list. Index position of this element in the list is 1. So therefore we will return value 1 and we will stop the search process because if element is found there. Suppose if the key value is not equal to here, then we are going to divide this list into 2 sublists. Since elements are there, 2 elements are there in this sublist. When you are dividing that element into again 2 sublists, in each sublist you are going to get 1 element. Okay, so this is how we are doing the search process. So in phase 1, 8 elements are there. In phase 2, we have come with a list with only 4 elements. In phase 3, we have come with a list with only 2 elements. In phase 4, suppose if it is there, phase 4, we may have a sublist with only 1 element. There we will stop the search process because that sublist cannot be further divided. Okay, so like this process is carried out until we found the element, or we will come across a sublist which cannot be further divided. Means the sublist should contain only 1 element. At that place we will stop the searching process because a sublist with 1 element cannot be further divided into 2 sublists. So this is how the binary searching process is carried out. Now let us take another case where the search element which we are selecting is not there in the list. Then how that searching process is being carried out? If you see that, it will be like this. Here same set of elements I have taken, and here the key value I have taken as 110. You know that when all these elements are arranged in the ascending order, the last element is there at index position 7 and its value is 94. So key value 110 is greater than 94, means key value is not there in the list, in this list. So we have selected a key value which is not there in the list, and we will see how this search process is carried out and how we come to the conclusion that the key value is not there in the list. So for Initially low is initialized with the index value 0 and high variable is initialized with the index value 7, means last element. Now for phase 1, first we have to calculate a middle element. Middle element is nothing but low plus high by 2. 0 plus 7 by 2 means it is 3.5, means its value is 4. So first comparison should be done with the element which is there at the index position 4. Which element is there at the index position 4? At index position 4, 48 is there. Compare key value with the 48. Check whether key value is equal to x of 4 or not. 110 is equal to 48? No, it is not equal. So therefore what we have to do? Check whether key value is less than this element. 110 is less than 48? No. If it is not equal to 48, definitely it is. If it is not less than 48, then definitely it is greater than 48. So 110 is greater than 48, we know. So therefore it is there. 110, if it is there, it should be there on the right half of the sublist, because all the elements which are there on the right half of the sublist are greater than middle element. Key value is greater than middle element means definitely this key value, if at all, if it is there in the list, it should be there on the right half of the sublist. So our search process will continue in the right half of the sublist. When you are going with right half of the sublist, the high variable value doesn't change. Only low variable value will change. It should be made to point out the first element of the right side sublist. So low is here. We have to make low to point out this element. This element index position is nothing but mid plus 1. So therefore, we have made low variable value is equal to mid plus 1. Mid value is 4. 4 plus 1 means 5. Means by the time phase 1 is over, the mid low variable value is made as 5 and the high variable value doesn't change. So in phase 2, we are continuing with the right half of the sublist. So for phase 2, the right half of the sublist is nothing but a sublist containing approximately 4 elements. Means here we have only 3 elements. Low variable value is 5, means this is the first element of the sublist, and high variable value is 7. So high is here. So low and high. Calculate the middle value. Middle value is nothing but low plus high by 2. Low value is 5, high variable value is 7. Low plus high means 5 plus 7 means 12. 12 divided by 2 means it is 6. Means comparison is to be done with the element which is standing at the index position 7, index position 6 in this list. The element which is there at index position 6 is 86. So comparison should be done with the 86. Let us check whether key value is equal to the 86 or not. Key value is 110. 110 is equal to 86. No, it is not equal to the 86. So then check whether key value is less than 86. No, key value is not less than 86. Means it is not there in the left half of the sublist of left half of the list. Okay. So key value is not less than middle element means definitely key value is greater than middle element. So therefore the search process should to be carried out in the right sublist. What is the right sublist of element 86? Only this list containing only one element. So we have to make low to equal to this sublist, because in the next phase the search process to be carried out in the right sublist. In the right sublist of this element, we are having only one element in the sublist. So low should be made to point out this element, because only one element is there in the right sublist. So both low variable value and high variable value is pointing out the same element, because it is the first element of the list, it is the last element, because only one element is there. Since only one element is there in the sublist, that is the first element and that is the last element. So both low variable value and high variable value should be made to point out this. High variable value we do not change, it is same 7. And low variable value we have to made it to point out this element. So how do you change low variable value? Low variable value is made to point out mid plus 1. What is mid variable value? 6. 6 plus 1 means low variable value is made as 7. Okay. So in phase 3, the low and high is pointing out a sublist containing only one element. Now compare the key value with this element by calculating the middle element of this list. How do you calculate middle mid value, mid element index value, it is nothing but low plus high divided by 2. Low value is 7, high value is 7. 7 plus 7 divided by 2. 7 plus 7 is 14 divided by 2. Means mid variable value is 7. Now in this list we have to compare key value with the element which is there at the index position 7. We know that only one element is there in that sublist, so therefore it is the first element, it is the last element, it is the middle element. So even when you calculate mid value also, it is pointing out the mid value is also pointing out same element of the sublist. Compare key value with the middle element to know whether it is equal or not. So it is not equal because key value is not equal to x of 7. Key value is 110. 110 is equal to 94? No, it is not equal to the 94. Can you divide this sublist further into two sublists? No. So therefore we will stop the search process because we have come across a situation where the sublist contains only one element. It cannot be further divided. So therefore we will stop the search process and we will return -1. -1 is returned to tell that the key value is not there in the list. So like that the search process is carried out. Means we will come to a sublist with only one element in the case where the key element is not there in the list, or in the worst case we will come to a sublist with only one element when the key element is the last element of the sublist. Then only we will come to this situation. Okay. So if the element is not there in the list, then immediately we will return -1. -1 is returned to tell that the element is not there in the list. Okay. So now, if you see here, again because it is not there, it cannot be further divided. How the search process is stopped means, because key value is greater than here the middle element of the list, 94. Okay, so on the right half of the element, do you have any elements? No elements are there. You are going beyond the limits of the array. So therefore we will stop the search process. That is what it is done. You cannot go beyond the limits of the array. So therefore the search process is to be stopped there itself. Now what is the efficiency of binary search? So to calculate the efficiency of binary search, first we will concentrate only most probably on time complexity, because space complexity is same for all searching processes. So time complexity, how many comparisons it will take? Assume that the list contains n elements and n is power of 2. Why we have taken the number of elements as power of 2 means you will get because we are comparing the key value with the middle element. And after comparing with the middle element, we are dividing that list into two sublists, left side sublist and right side sublist. When you take the number of elements in the list as power of 2, so when you are dividing a list into two sublists, in each sublist approximately you will get equal number of elements. So for that purpose, I have taken the number of elements in the list as power of 2, means n is equal to 2 power m. So from this you can get that m is equal to log n base 2. Okay. Now see, if you consider the time complexity of best case means the comparison should stop early. So when the comparison should stop early, so if the element is, because we are comparing key value with the middle element of the list. So directly when you are doing the first time comparison with the middle element of the list, given list, if the key value is directly matching with the middle element of the list, with only one comparison you will find the key value in the list, and then we will stop the search process. For this only one comparison is required. So therefore time complexity for best cases can be said that it is order of 1, because only one comparison is done. Okay, so therefore time complexity is order of 1. So this best case will come only when the key value is found exactly in the middle of the given list. Then only the best case will come. But probably in many cases the search value for which we are going to search the list, that the search value may not be there exactly in the middle position of the given list. So in that case we have to search the list. And let us see the worst case situation. Worst case situation will come with two possibilities. First possibility is when the search value is standing either at the beginning of the list, given list, or at the end of the given list, then only worst case situation will come. Or another situation is when the key value is not there in the list, given list, then the worst case situation will come. So in both of these cases, what are the two cases? One case is, first case is the search value is there at the beginning of the list, given list, or at the end of the given list. That is the first case. And second case is the key value is not at all there in the given list. So in these two cases, you have to go on dividing the given list into sub list until you will get the sub list with only one element. This is the worst case. So in this process, in phase 1 you are having n elements, in phase 2 n by 2 elements, in phase 3 n by 4 elements, in phase 4 n by 8 elements. Like that, the number of elements in each phase will be reduced by 50%. At some phase you are going to get a sublist with only one element. But how many phases will be there? If n value is equal to 2 power m, so you are going to get m number of phases. So therefore m number of phases are there. In each phase we are doing one comparison. So therefore total number of comparisons required is m number of comparisons. So number of comparisons are equal to m. But we know that m is equal to log n base 2. So therefore number of comparisons are log n base 2. So time complexity is log n base 2. Means in the worst case, time complexity of binary search is log n base 2. But what about the worst case linear search? The worst case time complexity of linear search is log n. So worst case time complexity of linear search is order of n. But here worst case time complexity of binary search is log n base 2. So log n base 2 is far less than the order of n. So therefore we can say that binary search is more efficient than the linear search even in worst case situation. So that's what we told in the beginning, that binary search is most efficient than the linear search. But the limitation with the binary search is it can be used only on ordered lists. That is the limitation of binary search. Then average case. Average case means the element is lying in the list somewhere. So in that case, you require fewer than m number of comparisons. And we are taking that off of the m number of comparisons, means m by 2. So therefore log n, m value is equal to log n base 2. So therefore log n base 2 by 2 comparisons are required. Since it is also equation in terms of log n base 2, so time complexity even for average cases approximately is equal to order of log n base 2. Means the number of comparisons required is far less than the order of log n base 2 for the average case. And in the average case also, compared with the linear search, binary search gives more efficiency. Average case time complexity of linear search is order of n. And here average case is order of log n base 2. So log n base 2 value is far less than the n. So therefore in the average case and worst case, the binary search time complexity is much better than the time complexity of linear search. Then what is the space complexity? Space complexity means it is the space occupied by the values, all set of values to support the binary search. And here we are working with n set of values. So to store n set of values, assume that we are working with a 16-bit machine and we are working with integers. And each integer require on a 16-bit machine 2 bytes of space. We are working with n integers, n set of integers. So therefore to store n set of integers you require 2 n bytes of space in the computer memory. So therefore space complexity is 2 n bytes, plus if you are using space for any other additional variables to implement your searching algorithm, so then that space required for additional variables. Here we have used low variable, high variable, mid variable, like that. So you calculate how many additional variables you are using. other than this n variables, n set of values. How many additional variables you are using? So the space required for those additional integer variables, that is also getting added to the space complexity. Okay, it is also coming as order of n approximately. The space complexity for linear search and binary search is same. It is order of n. Or if you want to say exactly, it is 2n bytes space plus the space required for additional variables. Then pseudocode for binary search. After discussing the methodology for binary search, now we will try to implement the pseudocode for binary search. What is the pseudocode for binary search? Here we have implemented a procedure called B search. B means binary search. So this procedure is expected to receive 4 arguments. First argument is array X, where the set of values are stored. And second and third argument is low variable and high variable, which are pointing out the first element and the last element of the list to be searched. And then fourth argument is key variable, and which stores the search value, which is for which we have to search the elements in the array X. Now we are defining a variable called mid variable. So we are going on repeating this procedure as long as low variable value is less than or equal to high. When the low variable value greater than high, we will stop the search process. Means we will come to low variable value is greater than high only when all the elements of the set elements of the list have been searched, and it is not possible for us to further divide the sublist into 2 sublists. So in that case, the low variable value is greater than high. So at that place we will stop our searching process and we will return a value -1. So that is the worst. In worst case, we are going to reach this situation. But if the element is there in the list, our search process will ends prior to that. And before we are going to reach low value is greater than high, our search process will be stopped. So first we are calculating the mid variable value. Mid is equal to the low plus high divided by 2. So we are comparing our key value with the middle element. Key is equal to x of mid. If it is equal to mid variable value, then immediately we are returning the index position and the searching process will be stopped. If the key variable value is not equal to the middle element value, what we are doing, then we are checking whether key value is less than middle element value or not. If key value is less than middle element value, we know that key value is there on the left half of the sublist. So therefore, we are changing the value of the high variable value. High variable value is made to point out mid -1. Okay. Suppose if the key variable value is not less than mid value, then we know that key variable value is there in the right half of the sublist. So therefore, we will change the low variable value. Low variable value is made to point out mid +1 element. And the process is continued, and this process is going on repeated till the element is found. If the element is not found, then low variable value is greater than high. At that point we will stop this while loop and we will return a value -1. The same procedure, whatever procedure we have discussed, the same procedure we have implemented in terms of pseudocode. So this same procedure, step 3, 4, 5 and 6 going on repeated till the low variable value is greater than high. So that situation we will reach only when the element is not there, or when the element is there either as the first element of the given list or last element of the given list. So this is how we will try to implement the pseudocode for the algorithm. Now from this pseudocode, it is easy for you to write the algorithm. Algorithm is nothing but it is a sequence of steps written using English sentences or English phrases. So these statements you can convert into a suitable English statement in the same manner. So that becomes an algorithm. So writing algorithm in English sentences is left as an exercise to you. In the examination, they may ask you to write the pseudocode or algorithm. Whatever they are asking, you write both pseudocode and the algorithm in the examination. Now we will try to develop a C code for the same steps of the pseudocode. A C function code for the binary search. So binary search function named it as bsearch, and it is specified that it is returning an integer value. So that integer variable value is nothing but the index position of the key value in the list, or it may be the value -1. So -1 is returned only when the element is not found in the given list. The search value, whenever it is not found in the given list, we will return value -1. Otherwise, we will return the index position of that element in the array. So therefore, both these values are integer. So therefore, return type is mentioned as integer. Now let us see what are the arguments. Same 4 arguments it is expected to receive. First argument is array x, and then second and third arguments are low variable value and high variable value, which are pointing out the first element and the last element of the list to be searched. And fourth variable value is key value. The key value contains the search value for which we have to search the array x. We are going to search for the value contained in the key variable value, and search is done in the array x. And inside the function we have declared a variable mid. Okay, so the variable mid is made to point out the index position of the middle element of the list to be searched. See, the algorithm is repeated as long as low variable value is less than or equal to high. So we are calculating mid variable value. Mid is equal to low plus high by 2. And key variable value is compared against the middle element value. If key value is equal to the middle element value, then we will stop the search process by returning the index position of the middle element, that is mid. Otherwise, we will check whether key value is less than the middle element value or not. If this condition is true, then we know that key value is there on the left half of the sublist. So therefore, we will change the high variable value to made it to point out the last element of the left side sublist. That is nothing but the last element of the left side sublist is there at the mid -1 position. So therefore, high is initialized with high is assigned a value mid -1. Suppose if this statement is not true. This statement is not true means definitely key variable value is greater than middle element value. Means key variable value is greater than middle element value means key variable definitely it is there in the right side sublist, right half of the sublist. So when you are continuing search process in the right half of the sublist, you have to made low variable value to point out the first element of the right half of the sublist. The first element of the right half of the sublist is found at index position mid +1. So therefore, low variable value is assigned a value mid +1. The search process is continued as long as low variable value is less than or equal to high, or until it come across an element. When it come across the element, immediately search process is stopped and it returns mid variable value. Otherwise, search process is repeated till low variable value is greater than high. So low variable value is greater than high only when the element is not there. So at that place, we will stop the while loop and we will return a value -1 to tell that this element is not there in the list. This is how the search process is carried out. Now, once you have a C code, then we will try to develop a complete C program for binary search. The complete C program for binary search is like this. We have declared the prototype declaration of the function bsearch, that it is expected to receive 4 arguments. The first argument is array x, second and third arguments are low variable value and high variable value, pointing out the first element and last element of the list to be searched. Fourth argument is a key variable which contains a search value, and this function returns an integer value to the calling function. That integer value is maybe the index position of the key value in the list, or it may be a value -1 to tell that the element is not there in the list. So now we are starting the main function. Inside the main function, we have declared an array x with a storage capacity of 20 integer values. It has capacity to store integer values, and then we have declared a variable key which we are using to store a search value, and then we declared an integer variable n which represent the number of integer values stored inside the array x, and other variable I is used as a loop control variable to keep track of the element in the array x, and another variable r which is used to hold the value returned by the bsearch function. So first we are asking the user how many integer values are there. User may enter a value as 5 or 10 or 15. So we are instructing the computer to read that integer value and store inside inside variable n. So now n represent how many integer values are available with the user, and all that integer values we will read from the user. So n represent the number of integer values available with the user. So now we are asking the user to enter all that integer values in a row in the ascending order. So here we are assuming that user is entering all the values in the ascending order, because binary search is used only on a ordered list. Here we are considering ordered list as a ascending order. So we are asking the user to enter all the elements in the ascending order. We are instructing the computer to read each of those integer values one by one and store them inside the array x from index position 0 to up to n minus 1. Then we are asking the user to enter the key value, search value. So we are instructing the computer next to read that search value and store inside the variable key. Now what we are doing is we are printing all the values stored inside the array x from 0 to up to index position n minus 1. Whatever values are given by the user, we have stored them inside the array x. All that values were displaying on the screen. Now we are making a call to binary search function by passing first argument as array x, second argument as first index position of the first element, and third argument as the index position of the last element n minus 1, then a search value. Then the main program is stopped here. Control is transferred to the binary search function, and all this binary search function code is executed, and finally it returns some integer value, and that integer value we are holding in variable r. So binary search function, what it will do when it is called, it will try to find out the position of the key element in the list. If the key element is found, it returns the index position of key element. If the key element is not found in the list, it returns minus 1 value. So whatever integer value it is returning, we are storing that integer value inside the r. Now we are checking whether r value is equal to minus 1 or not. If r value is equal to minus 1, we know that that element is not there. Key element is not there in the list. So therefore we are displaying a message that the key element is not there in the list. If r value is not equal to minus 1, then we know that that element is there in the list. So therefore we are displaying a message that the key element is found at a percentile d index position in the list. In the percentile d position, we are printing the value stored in the variable r. The variable r contains the value returned by the binary search function. So that value we are printing. That value is nothing but the position of the element in the list. Then we are closing the main program. Main program is closed here. Okay. So that is how we are writing the program. So this is the complete C program. Same function, binary function code we have returned after the main program. Okay, so that function is called and it searches for the key value in the given list of elements. Now what are the important questions related to this class? So first question is explain binary search with suitable example. So for this you have to write the little information about the binary search and the assumptions that we have to take, and then procedure, and explain the binary search with the example. You can explain for case 1, or if you want to explain case 1 and case 2, means when the element is there, how the searching is done, when the element is not there, how the searching is done. Or you can explain only for the first case, when the element is there, how the searching is done, you can explain only for that. So it is left to your choice whether you are going to explain for both the cases or for first case. So that is left as a choice to you. And if you are asked to write the answer for 10 marks, you explain both the cases. If you are asked to write the answer for 5 marks, you explain only for case 1. And then write a pseudocode and algorithm. Pseudocode is given to you, and algorithm, I already told you, it is an exercise to you. So from pseudocode, you convert all that statements into English sentences or English phrases. That becomes an algorithm. Write a program for binary search. So already we have discussed the program for binary search. So that program you can write and explain it in your own sentences. So this is what today class. And if you are having any doubts about this class, you can call me on 9848919656 between 9:30 and 5 p.m. Okay, so thank you for your patience listening. Thank you all.